Hello everyone, my name is Matthew Catadella. I'm here to start the briefing on the internal combustion engine for this week's project and discussion posts. If you could just bear with me, I do need to move my video view around a little bit. Still getting used to this software, finally got it working. So if you can just bear with me, it'd be greatly appreciated. And let's get started. All right, contents of this brief regarding internal combustion engines, or ICEs. We're going to have our technical description, basic principles, key components, fuel types, engine types, functions, applications, and new advances in the field or pertaining to internal combustion engines. So we're going to define an engine. Engine is a machine designed for converting various forms of energy into motion and mechanical force. In this case, combustion for fuels, or of fuels rather, for energy resulting in a force applied creating motion. Power generated by the motion is measured by torque, horsepower, and thrust, which is going to be your byproduct of the burning the fuels internally. I'm going to move myself off screen here. As you can see to the right, we have two different types of engines. Illustrations here. This would be your standard piston engine or internal. There's many different formats for that. And then your external combustion engine, where your fuel is being combusted externally of your power source or your mechanical power, or rather mechanical surfaces that are being contacted during combustion. An internal combustion engine, combustion occurs within a vessel internally within a chamber, with the energy produced acting directly on the mechanical surface, as you can see here. External combustion engine. Combustion still occurs within a vessel, however, heat generated is used to create pressures, generally steam or water, to drive a mechanical component. As you can see, your steam is driving your mechanical component there. Basic principles of all internal combustion engines. I'm going to illustrate them here. Your intake, or suck, is the air and fuel being sucked in. Your squeeze is your air and fuel being compressed. Your bang is going to be the ignition or the explosion, and the blow is going to be the exhaust gases blown out. This sequence is the basis for all internal combustion engines, to include turbine and turbojet and turbofan engines. If you look at the illustration here, over on the left-hand side, you're going to be sucking intake in through here. It's going to get squeezed through here, combustion chamber internally here, and exhaust out through the back end. On a piston engine, it would be sucked into the cylinder, and the rotating piston assembly would be your mechanical part that is taking or receiving the energy from the combustion. Just to reiterate, mechanical force is derived from the energy produced during combustion, and mechanical surfaces would be the vanes in the jet engine or the pistons in the pistons engine on the right. Gases either push on the vanes or pistons to create motion. So if you look here on the bottom right, this is your rotating assembly, this is your piston, your mechanical machine that is making contact with the combustion and receiving the energy as a result of the combustion. And if you go over here on the top left, this shows various stages of a jet engine or a turbojet engine, which could be used to run a turbofan. Note that this is more linear in nature as opposed to a piston engine, which is more of a rotating assembly. Motion converts to mechanical force. Torque is going to be the rotational force created by the pistons or vanes, pushing or turning a shaft, as I showed in the previous slide with the piston engines. And horsepower is a unit of power produced based off torque and the rotational mass of the engine. There's a lot of factors that factor in the horsepower, but what you're going to receive is torque. That's going to be your main mechanical motion that's going to get the ball rolling in producing power. Thrust is the amount of directional pressure derived from jet exhaust or additional air from fans driven by a rotating shaft. Think torque, rotation, think aircraft turbofan. So regardless of the engine type, you're going to have torque as a byproduct of your combustion cycle as a rotating movement to create power. Just move myself out of the way here. All right, there's all kinds of fuels that can be used for internal combustion engines. As you can see, everybody probably knows about gasoline, diesel fuel, which are your most common road fuels. Certain generators run off of propane or LPG, which is a gaseous fuel, hydrogen, which is new technology that companies are working on, is an internal combustion fuel, and obviously your jet fuels for aircraft and biofuels for certain trucks or diesel engines or generator purposes. Different fuels create different energy outputs based on the type of engine and other factors. Some new advances, like I said in the previous slide, are biofuels, will help reduce the amount of fossil fuels used. Hydrogen, as stated in the previous slides, and increased use of power adding turbochargers in a lot of the newer vehicles and internal combustion engines. They're using turbochargers to increase efficiency, and also polymer technologies that are reducing weight for engine components. And just to go over what I just kind of talked about a little bit, our applications for all these engines are road vehicles, transportation, power generation, aircraft, and pumping stations, anywhere where mechanical power is needed. I hope you were able to bear with me here during this presentation, especially me moving myself around here. I'm still trying to work this out. Thank you very much, and I hope everybody has a great week.